Hello, everyone. This is section 3.6, which is basically in this section, I will be doing two word problems. Okay, so this section is related with the word problems. Okay, so but before we start doing the word problems, we need to know a few things first. So as we know that, let's say if I write, uh, let's say y prime. Well, we know that this is the derivative of y, or I can also say that dy over dx, right? So basically, what we're saying here is we're saying that we're taking basically the derivative of y in terms of x, and also there is another meaning of this. This also means rate of change of y. So this also means the rate of change of y. So it says at what rate the y is changing it. That what this thing means. All right. So let's say if I write, instead of saying dy over dx, well, I can also say dy over dt. Well, basically, again, it's the same thing. This is also a rate of change of y. But here we have t on the bottom. Well, it's a variable, right? It doesn't matter. But here, well, when you write t, generally we can think t as a time. So basically, let's say if I say dy over dt is equals to, let's say, 3 feet per second. So that means, as I said, that dy over dx or dy over dt means, well, this means the rate of change of y. So here, this well, if I have dy over dt is some value, then this means the y is changing 3 feet in every 1 second, right? Or if I write dx over dt, let's say 2 feet. Well, instead of writing per second, I can also write, instead of writing per, I can say this. So here, this means the rate of change of x per second, right? So basically, this means rate of change. That's what I'm trying to say. This means rate of change. All right, just keep that in mind. Okay, so now after we know this idea, we will be doing this problem first. All right, so let's try to understand what this problem is saying first. So so here it says that so a 26 foot ladder is placed against a wall. So let's say there is a wall. Let's say this is a wall, okay, which will be in vertical directions, obviously, right? The wall will always be in vertical directions. We can just think that in a general way, right? And then if the bottom of the ladder is moving away from the wall at 3 feet per second, and at what rate is the top moving down when the top of the ladder is 20 feet from the ground? So let's say there is a ladder placed. Okay, so there is a 20-foot ladder. So there is this is a ladder placed against this wall, and this ladder is 26 foot, and the wall. So as this one says that at what rate is the top moving down on the top of the ladder? So this is the top of the ladder, is 20 feet above the ground. So that means this is 20 feet above the ground, which is placed against the wall. So that means this should be a 24, right? So the wall here is going to be 24. The ladder is 26. All right. So now the thing is, what about the length of this, or length of the floor? Okay. So now let's just assume this as X. Well, we know this already, but let's name this. Let's say Y is equals to 24. And this one, you can name this Z, right? So first, what I can do here, first, looking at this problem, looking at this thing, since I can now treat this as a right angle triangle, so I can now directly use Pythagoras theorem, right? So I can say that x squared plus y squared, x squared plus y squared is equals to 26 squared, right? And then from here, I can find the value of x. So y, well, first x squared plus y is 24. 24 squared is equals to 26 squared, or x squared is equals to 26 squared minus 24 squared. And then x is equals to plus minus, right? We have to consider plus minus. But since here we're considering the length, so the length generally, well, length, we don't consider the negative because length cannot be a negative. All right, the direction can be negative, but just the length cannot be negative. So we don't have to consider the negative. So square root of 26 squared minus 24 squared. All right, so from here, after using calculator, x, you'll get x value 10. All right, so the x value, we got 10. Okay, so the thing, but here now, if you read this line, it says that if the bottom of the ladder is moving away from the ground at 6 feet per second, if the bottom, well, if the bottom of this is moving away at the rate of 6 feet per second, so that means this x is changing at the rate of 6 feet per second. So that means I can write the x is changing. So the change in y, or the rate of change of x, let's say in terms of t, is 3, because I have 3 feet per second. So let me just write 3. Okay. All right. So now from this, well, as we know, let me just write this equation here again. So as we know this equation, we know this x squared plus y squared is equals to 26, right? And now we are trying to find at what rate is the top moving down. So we need to find at what rate this is moving down. So, or basically at what rate y is changing. All right, we need to find that. So what we can do here is, well, we know dx over dt, we know x, we know y, but we don't know this dy over dt. So what we can do from this equation is we can basically take the implicit differentiations. Well, we learned this on section 3.5, the previous video. So go back and watch the previous lecture 3.5, all right? So the implicit differentiation here, I'm taking implicit differentiation, or let me just write ID in terms of t. All right, so we're considering this in terms of t. Okay, so now when I take the implicit differentiation in terms of t, so this first one, I have to take the difference derivative of this whole thing, which will be 2x, all right? And then now just take the derivative of this inside, which I can write just x prime or dx over dt, all right? On my previous video, when I took the implicit derivative, I just wrote this 2x. I didn't write this extra term, because in that case, I was taking in terms of x in the previous video, but here I'm taking this in terms of t. That's why I have this extra term. Plus, again, when I take the implicit derivative or implicit differentiation of this whole thing, first I have to take the derivative of this whole thing, which will be 2y times y prime or dy over dt. So this is 26 square. And if I take the derivative of this, which is basically a number, even if you take the 26 square, you'll get a number. So differentiation of a number is always 0, right? If you take the derivative of number, it's always 0. All right, so now we have an equation where I can use some of these values. So, okay, I know the x, the value of x, right? I know the value of dx over dt, which is given. I know the value of y. I don't know the value of dy over dt. That's what we are trying to find. All right, that's exactly what this was asking here. All right, so let's plug in this value here and see if we can get the answer. So, okay, so 2x, we said x is 10, dx over dt is 3, plus 2y, or sorry, y, we know the value of y, which is 24, and dy over dt is equals to 0. All right, and from this, well, 10 times 3 is 30, 30 times 2 is 60, plus 48 dy over dt is equals to 0. So here I can move this to other side. So 48 dy over dt is equals to negative 60. So dy over dt, well, negative 60 over 48. Well, if you use a calculator, you'll get negative 1.25. So here we got a negative number. Why do we have a negative number? The reason is, if you see this, it's going down. So it's going towards negative direction. If it is going up, that means it is going towards positive directions, right? Because when you see the general graph x-axis and y-axis, well, if you see upward, it's a positive direction, downward, it's a negative direction. On x-axis, right is a positive direction, and the left is the negative directions. All right, so since this is going down, that's why we have a negative. Okay, so that's what we're looking for this problem. Now let's look at the next one. Okay, so the next one here we have, okay, suppose a point is moving along the graph of this x squared plus y squared is equals to 25. So if you see this, this is basically a graph of a circle, or this is the equation of a circle. So we know the general equation of the circle is x minus h square plus y minus k square is equals to r square, where r is the radius, right? And this h and k are the center. But since here we don't have anything for h and k, so the center is 0. And there is a circle. something like that. All right, and here it says when the point at the point here, negative 3,4, where x coordinate is increasing at a rate of 0.4 unit per second. Now we need to find how fast is y coordinate changing. All right, so here, as we know, well, the equation is given x squared plus y squared is equals to 25, right? And we know that the x is given, well, x is negative 3, y is 4, and also the x coordinate is increasing at a rate of this, so we know that the change in x, the rate of change of x is dx over dt is 0.4 units per second. Let me just write 0.4. All right. So this, well, we know these informations from this problem. All right. So now we need to find the rate of change of y, or we need to find dy over dt, just like we did on the last problem. Okay. So again, using the same idea here, we know the equation. So I can use the implicit differentiation of this equation. All right, so take the implicit differentiation in terms of t. Okay, so that means, okay, I have to take the derivative of this whole thing, which will give us 2x, and then again take the derivative of this inside, take the derivative of this x, which will, in terms of t, right? So dx over dt. Again, same thing for this one, 2y, and the derivative of y in terms of t is dy over dt, and the derivative of this number is 0. All right, so now we know x, right? So we know x, we know dx over dt, we know y. So now we need to find dy over dt. We know dx over dt, so we need to find dy over dt. Okay, so now 2 times x is negative 3, dx over dt is 0.4. 2 times y is 4. dy over dt, we don't know that. We need to find the value of this is equals to 0. So from here, okay, so from here, what we get from here is, I'll use a calculator, 0 times 3 times 0.4 is 2.4. Or since there's a negative, so negative 2.4 plus 8 over dy over dt is equals to 0. Now move this to the other side, so 8 dy over dt is equals to positive 2.4. And if you divide 8 on both sides, then dy over dt is equals to 2.4 divided by 8 is 0.3. So it's 0.3 unit per second. All right. So yeah, the idea here is the implicit differentiation, and you need to understand the idea of this. Well, when you see this means the rate of change of x, or when you see this means the rate of change of y. All right. Okay, so I showed you two problems here. So yeah, that's it for this section. All right, so I'll see you in the next video. Thank you.